Hi guys, I'm so happy to teach you this today. Unit 5, Lesson 1, Operations on Functions. All right, adding, subtracting, multiplying, dividing functions. We've kind of talked about all of these before. We're just going to kind of put it together, a little bit of a refresh kind of section. This one's super fast today, so that's exciting. So this key concept box is found in our textbook on page 271. So you guys can pause the video if you want to take your own notes, or if you want to follow along in your books, that's fine too. It's on page 271. But let's go through and we're going to look at this example 1 that says, given f of x being x squared minus 4 and g of x being 2x plus 1, find each function, indicate any restrictions in the domain and range. So part A says find f plus g of x, which means we're going to take whatever f of x is and we're going to add it to g of x. So we've got x squared minus 4 plus 2x plus 1. Now, this is just to keep it separate as here's f of x, here's g of x. Well, that was up in my notes. Yeah, I'm having a little fun today. So now we can just simplify this. We can combine like terms. We can just, do our thing here. We've got x squared and then plus 2x minus 3. From here, that's about all we can do. There are no restrictions on the domain or the range because we are capable of plugging any value in for x. There are no restrictions, which means the range also has no restrictions. So B comes after A. Part B says f minus g of x, and this is where parentheses are going to really come in handy because you've got f, which is x squared minus 4, minus g of x. So this minus is going to be distributed into both. So we'll have x squared minus 4 minus 2x minus 1. So simplified is going to be x squared minus 2x minus 5. Again, there are no restrictions, so no restrictions, and then no restrictions. Okay, example 2 is given f of x being x squared plus 7x plus 12 and g of x being 3x minus 4, find each function. Indicate any restrictions in the domain or range. So this time we are going to multiply both of these functions. So I'm going to take x squared plus 7x plus 12 times 3x minus 4. So this is going to require a lot of the distributive property and making sure each piece gets multiplied to all of the other pieces. So I'm going to take my x squared times 3x is 3x cubed. X squared times a negative 4 is negative 4x squared. 7x times 3x is 21x squared. 7x times negative 4 is going to be negative 28x. And then we've got 12 times 3, which is 36x, or 3x. 12 times negative 4 is negative 48. So I'm going to combine all of these like terms. So this is going to stay 3x to the third. Negative 4 plus 21 is going to end up being a positive 17x squared. Negative 28, so 36 minus 28 should be 8. So plus 8x minus 48. So there is the simplified form of f times g of x. There are no restrictions because, again, this is just a straightforward polynomial. There's nothing being divided. There's no asymptotes that would be on the graph. I know we haven't quite talked about that in a while, so no restrictions. All right, the next one, we're going to take f divided by g of x. So we're going to take x squared plus 7x plus 12, and we're going to divide it by 3x minus 4. That's all we really need to do here. I'm not going to ask you guys to go through and divide it. It's just showing what that would look like. We do have a restriction here, though. The denominator, 3x minus 4, is not allowed to equal 0. Okay, it's not allowed to equal 0 because we can't divide anything by 0. We can't put something into 0 groups. So 3x equals 4, x equals 4/3. So we cannot have x equal to 4/3. So your domain restriction is 4/3, which means x cannot be 4/3. And that's all you need to know for today. Easy peasy lemon squeezy. I'll never say that again.